The presentation will focus on real CISO challenges and problems, and I'm going to do a little bit of prediction on how it will help solve those problems and how AI will help solve those problems. So first, we need to start with some basics around AI. What are its strengths and what are our limitations? What's really interesting about it is most people thought initially if AI were to come around, and by the way, when I say AI, I mean Gen AI, and I mean specifically LLMs. They thought, oh, it will take care of like lower tier things, like very simple automations. That's how what AI will do. People thought, oh, it's all the minimal basic stuff. But actually what Gen AI has actually started to be very good at is things that most people thought were the last things that AI would be good at. Creativity, reasoning, logic, very, very good communication skills. All the ability to take in data, synthesize it into the thing that matters the most. So it's really amazing that that's stage one for where AI is today. Now, if you've worked with AI, I think the quote that is the most common, if you've done with this, is AI is basically like working with a genius 13-year-old, overconfident with short attention span and no street smarts. That is definitely what it's like working with AI. So by the way, if you're looking to hire prompt engineers, I highly recommend middle school teachers. I bet they would be fantastic at being a prompt engineer. Okay, so I want to get some fundamentals because you need to understand what AI is good at versus what it's not to really think about, well, let's start predicting a little bit about where AI is going and how it will evolve. So the title of this slide is What is Here Today but Coming Tomorrow? Now, it's a little bit of an unusual title, but it's because most of what I'm going to talk about here actually does exist today. The technology's there, the white papers are there. Some of this is actually being worked on and is working today. However, it's just not ubiquitous. You're not seeing this displayed everywhere. So this is here, although it just hasn't gotten here. So if you think about a year, maybe 2 years from now, it will come. I'm just going to go through the talk, and then when it comes up, it comes up. So some of the first things that we need to think about. So context awareness. So for those of you who don't know, LLM specifically, it's about context. You can think about this short-term memory, right? So when you pass things to an LLM, it remembers what you pass, but it's very, very small today. If you think about it in old school days, it's like the equivalent of using 64K of RAM. But as we start getting further along in our technology, context windows are going to start getting very, very big. For example, Gemini out of Google now has 1.5 million context tokens of windows. And then actually what you really want to start seeing is you want to start seeing the ability to pass gigs and gigs of log data to an LLM and it reason about it. That's when context windows become very large and when LLMs can start processing things like real-time data. That is when things get very, very interesting around what you can do with LLMs. Number two, continuous self-improvement. So today, LLMs are very distinct in the way that they operate or the way that they quote unquote learn. As an example, I have a context window. I can work within the context window. And if I have a lot of data that I need reference to, think about your enterprise corporate data, people use RAG or a vector database to reference that data so that they can learn and understand about it. And then you've got your fundamental model itself. And some people, if it's an open model, they'll fine-tune that model to be specialized in its expert or in its content. These are very, very distinct phases. But actually, I think in the future, as we start moving forward, these phases will no longer be manual phases. I think these things will start automating itself. So think about things when I say the word continuous fine-tuning, what that might mean. And that actually opens up some amazing thoughts around how LLMs will self-learn new skills. Third, localized intelligence. We know for a fact that models are getting smaller and cheaper to run every single day. If you think about it from a consumer perspective, Apple has already released their models for what's going to run on your iPhone, what's going to run on your watch, what's going to run on your toaster oven. Like models will get localized and will run on very, very small things. But not just about consumer, but think about enterprise. So for example, what happens when models start running inside your containers? Every container has a model that runs inside of it. Lambdas or functionless code has models that run inside of it. This really start thinking about, oh, this is very interesting when you start thinking about this at scale. And by the way, once you start getting these localized models, they start acting like agents. You've heard about agents before, but This is no longer about LLMs just consuming text and regurgitating or creating it. This is about agents making decisions and acting upon them. So if I took an LLM and said, hey, here's a bunch of tools and utilities /user bin, or here's all of the Google search, all of a sudden agents can start making decisions and start automating. This becomes really phenomenal in terms of being able to replicate work. And then finally, low cost. So at inference, these things are getting lower and lower in cost. For example, today they've already proven you can take a 70 billion parameter model, make it a 7 billion parameter model, and get about 80% of the effectiveness of a 70 billion parameter model. That means you can run that on local today's MacBooks or hardware. Think about that getting smaller and cheaper. Let me talk about high performing. At inference, when you talk to a model, you know how it thinks and it types back to you in pretty slow ways in like ChatGPT? Today, the cutting edge in terms of performance and speed, which is you have to take a model, burn it on a chip, is you get 600 tokens per second, which today, when you see the demos, is amazing. However, we know that coming in the next year, these things are going to get at 100,000 tokens per second. So think about the instantaneous reaction you're going to be able to get out of LLMs. This means things like robotics and other areas where you need real-time information and decision-making start becoming really probable. I'm setting up a little bit of prediction around how AI is going to evolve. Why is this important? It's important because in order for us to understand how it affects security, we need to know how AI evolves. Okay, now we can move to the next slide. Now watch it not work. Hold on. Okay. We also need to learn what is AI's impact on the enterprise. And AI's impact on the enterprise is these are top 4 things. If AI moves to there, these are the kinds of things that will happen. For example, I'm only going to talk about one here, but think about all meetings and communication will be analyzed and searchable. Think about this. Every enterprises run on meetings. We all know that. That's 90% of the time they run on meetings, which we all hate, but it does happen. But today, all of these things, these meetings are ephemeral. You don't know what happens in meetings. There's no log necessarily of meetings. If you've been using an AI note taker, by the way, for meetings, which I've been using them for 6 months, they are phenomenal. I've been using it. It's guaranteed enterprises are going to start mandatory these things in all of your meetings. Why? Because they're extraordinarily good at what they do. And 2, you can now take things that will ephemeral data and actually make them log it, and you have a record of it. Now, all the security people there, I know what you're thinking. Privacy, security, access control. I want you to, I get it, put it away on the shelf for just a little bit and think about what will happen. This is not a FUD talk, remember that. But I get what's going on in your head. But the organization will change. Information that used to be today not accessible is going to be accessible. Also, how is this going to affect engineering? Because in security, engineering is your biggest partner in what you do and how you work. Things like code and cloud will be self-documenting. So for example, today, AI is great at doing comments in code. In fact, it's way better than any engineer. So if you think about functions in code and AI is commenting on them, abstract it. Well, if they comment on the functions, they could probably summarize the class. They can summarize the library. They can then summarize the app. So every time someone writes code, it can get commented and it will be a document that will live and update itself. That's phenomenal. That does not exist today. Or let's talk about requirements being the way at which you code. Because today, people go and code, requirements are built, but they're not really looked at, and they never really update. But actually, when you start looking at Copilot and where this is going, that is going to be how you start programming. Delivering really strict requirements and seeing how that code changes. And finally, integrations, I think, will be automatic. It's very easy to give, even today, an LLM a API documentation, and it will automatically generate the client library in order to communicate with it. So this means products talking to each other that used to require a lot of work, I think are going to start becoming seamless and be able to talk to each other. And finally, agents. These are things that I call oracles that will sit that know specifically about the technology. So think about this. AWS has already released a version of this where you will have a model that is very specific to AWS that knows its ins and outs, knows how it takes actions, at which you can query about your environment, and it will tell you everything about your environment. Those agents will then start existing in all these various places. Think about it for meetings, email, Jira, whatever these things happen to be. I think this will start changing. Okay, now I've given you the basis of AI, how it's going to affect the enterprise. We can finally get to the CISO and how it affects security, right? So those are the foundations. Now, how's that going to affect us? So the first thing is, what are the CISO's top challenges? By the way, this is the #1 question I get asked all of the time as a CISO is, what are your top issues? And if any of you who are in CISOs, it all comes from VCs and vendors. They all want to know what your top challenges are. So I'm going to give you that answer. Not only am I going to give you that answer, but this answer is the same answer as it was 5 years ago, as the same answer it will be 5 years from now. So are you ready? So if you want to know what a CISO's top challenges are, I'm going to tell you this answer and you'll never have to ask it again. Here we go. #1, reporting. #2, budget. #3, talent. #4, relationships. #5, management. So this is actually the CISO's top challenges that they deal with every day. But like, this is, by the way, you can go to any CISO here at RSA and say, hey, are these your challenges? They'll be like, yep, that's exactly what that challenge is. But this is a security conference. We don't want to talk about things that, these are non-security related. So let's talk about the CISO's top security challenges that we want to address with AI. So these are the top 6. This is not a list that I produced myself. I actually interviewed 40 different CISOs and consolidated this information into what you're seeing right here. Now, what's interesting about this is actually this hasn't changed that much either. Look at vulnerability management, detection and response, reporting, compliance and measurement. If you would have asked a CISO their top security challenges 5 years ago, these would have been on that list. And I bet if nothing changes in AI, this will be the same thing that happens on that list 5 years from now. So then you have to ask the question, which is why? Why is it the same problems? Like, we have billions of dollars in security vendors in this market to solve the problem. Why aren't we solving the problem? And it's not because the security vendors aren't building products that are bad. It's because I think there's a lower layer fundamental problem. Underneath things like vulnerability management and detection response, there's an underlying foundational issue that products just cannot touch today because you can't get to it. And that is the thing that's not giving us the step up or the real disruptor that we need to solve these problems. So of course the question is, what are they? The 3 C's, coverage, context, and communication. You need to understand context and communication and coverage. Let me give you some examples of that. Context, this is the who, what, where, why, and how. Let me give you an example. You get a vulnerability that says you have a public S3 bucket. It is a high vulnerability. Is that true? Well, in an organization, it doesn't work that way. What you do is you say, okay, well, we have lots of public S3 buckets. Is this one that we know should be public? Who has that list? Yes, no, it's not. Yes, it is on that list. Okay, great, this is not a high vulnerability anymore. Or no, it's not on that list. Well, then great, you say, well, what's in the bucket? And if you go look in the bucket, if there's nothing in the bucket, then is this a high vulnerability anymore? No, it's not. Oh, but wait a minute, there's nothing in the bucket now, but what if there's something in the bucket later? Well, if you actually had context, there was an email thread where the developer actually said this bucket is sharing customer information with an external partner. So maybe there's nothing in the bucket today, but in next month there's going to be customer data in that bucket, which is now public. This is all context. This is the kinds of things that happens in security teams that is under the radar. It's like sort of the iceberg. All of the stuff that one vulnerability provides, this is all the work that needs to go to it to say whether this vulnerability should actually be rated high or not. Coverage. Coverage is my favorite topic. I actually believe most breaches are because of coverage. What do I mean by that? This is about width and depth. Let me give you an example. Let's take account takeovers. As a CISO, I set a rule that says, hey, 2FA is mandated for all employees of this organization. Security team goes out, we do all the hard work, 2FA is definitely mandated for all employees. All of a sudden, a breach occurs. Someone broke into, they did an account takeover of, let's say, our SaaS marketing system. Well, how did that happen? I thought we had 2FA mandated. And the answer you get back is, oh, we do, but those are contractors that have an exception to the rule on this cloud service. Coverage. It's the thing that fell through the cracks. It's the thing you just didn't see. Let's talk about logging. Let's say you're doing a post-mortem on an incident, and you're saying, why did we not see the lateral movement of this attacker? Oh, well, we were missing the logs. Or, hey, we were getting the logs, but the field that we had wasn't there. And then you start saying, oh my gosh, well, what happened? I thought we were getting logs. No, they stopped giving us logs a month ago. Well, how did we not notice that? I don't know. This is the gaps, the coverage. And finally, I won't go through all of these, but I know all of the security teams have a vulnerability management triage of issues where there is thousands of medium and low and high issues at which you haven't touched. Why? Because you just don't have the resources. That's the depth problem. Or in your incident response system, every alert that pops up, who goes and investigates every single low, medium alert across the board? Nobody. So the odds are the breach that occurred, you actually saw it, except nobody looked at it. That's coverage. Okay, finally, last but certainly not least, communication. This is the most important thing out of these three, and it's also the biggest waste of time. And let me tell you why. So your manager goes, as a security team, and goes, hey, how are we doing on those OKRs? What do? You say, okay, well, I got to go down over here. I got to tell my manager to then go to some IC to say, what are you doing? Are you doing work? Yes, I am doing work. Let me write a report about it. Oh, let me take that report, sum it up for you. Oh, let me take that report, sum it up for the board. Like this is big. And then that board looks at it and goes, okay, looks good. Like all that work that happens to say, how do we measure, how do we report things? Or when I ask a question like, what is the risk of this specific asset? What happens is there's not one product that will give me that answer. I have to go to my CSPM, get that answer. I have to go to the DSPM. I have to go to the ASPM. I have to go to the IAM. I don't even know what those letters mean. All I know is they are all these letters in different products that can all have to be merged into one report for the CISO to look at to say, okay, it looks like we're doing well here. This is communication. It's all about translation. Taking a core source of truth, translating it to your auditor, your manager, your regulator, your partner, your teammate, your product. This is where communication comes from. Okay, so I've told you all of these things. Talked about AI, talked about the effects of the organization, and about the three problems. So this is where AI comes in. I actually think these three problems are the three things AI actually excels in. Take, for example, coverage. If I can have 10,000 smart junior security engineers, what would I have them do? I would definitely have an engineer looking at every single write or object going into an S3 bucket. Is this sensitive? Is it not? Yes or no? I would absolutely have them triage the mediums, the lows, every single one of those things. I would have them monitoring the engineering Slack groups to say, oh, they're talking about this. Is this security related? Is it not? Should I do something about it? Should I not? I would absolutely have them looking at every log file going to every system to say, is this something suspicious? Is it not? These are things that 10,000 smart security engineers can actually do, and this helps in scale. Context. All this information that was available before is now available now. For example, let's take that S3 bucket issue. That happened in a meeting where they discussed and said, hey, let's open up this S3 bucket and we'll share it with our partner, and that's how this will work. Well, actually, if my agent could now search the contents of the meetings that happened to look for things around S3 buckets, it would actually pull this information out. So you could get this context right away. And communication, everything is about reporting. Okay, so here we go. I'm going to get to the good part. I want you to join me in walking through the world of today versus tomorrow. Now that we have those three, let's see what it looks like in the new world. Are you ready? Okay. Today, we have a new outbound call to Stripe.com was identified. This is what a detection analyst sees in their console. That's not very useful, right? You're kind of like, okay, great. What does that mean? Here is what this looks like tomorrow. It's one, it was identified and is being allowed. This is expected behavior and is considered low risk for the following reasons. One, Stripe is a trusted provider and only outbound calls are allowed. Two, engineering, documentation, and discussions have identified Stripe being the new accepted payment provider. Three, the Stripe libraries were introduced to code repo payment lib on this date. And fourth, we had an active, by the way, when I say we, AI, had an active Slack discussion with Cosmo, who is the main engineer, who did also approve Stripe.com should be allowed on outbound. This is the new world, and this is doable today. You can do this. All of a sudden now I have information that I can make a high confident decision. I don't need to go do all the research. I see it right here. I click great, approve. Next, vulnerability management. Everyone's seen this. A cross-site scripting issue was identified in an internal CIS system via the case commenting function. Great, what do I do with that? Is that high, is that low, is that bad, or is that good? Here's what it looks like tomorrow. Hey, by the way, total exposure time, 22 minutes. Oh, that's interesting. You can get that. It says at 3:35 p.m., this issue was identified by a nuclei assessment scanner. And by the way, I just want to read this. The issue is rated as low risk due to internal system, limited authenticated users, and it's on a staging system. Wow. You can tell that? Yes, you can. You could do this today. That is amazing. I've now known where it is, a critical system, a not critical system. Is it been exposed, is it not exposed? It says the issue was introduced in the last push. It also says it was done by Josh Smith, the engineer, and there was an automatic remediated PR for this issue submitted to Josh. Josh looked at it, reviewed it, he accepted it, and a new rule was added to our scanner, our code scanner, so it shifted left, right? And our requirements doc was updated for this issue, all automatically. That is amazing. And finally, crown jewel alert. If anyone's have done UARs, this is basically a permission. Hey, a request for delete access role was done on this bucket. Do you approve it? That's today. Tomorrow it says, our recommendation is to grant access for the following reasons. This request was made by the guy who owns the system. He's the principal engineer. Meetings with him and the team have discussed having edit and delete capabilities on this bucket. A JIRA ticket was filed for this already. And by the way, we went ahead and slacked your report who manages security engineering, and he thinks it should be approved. Great, approve. Okay, so that rounds it up. I hope that you've enjoyed the session, and maybe we'll see with what AI has done in the next couple of years, real changes happening to what we do. Thank you.